Graphing absolute value functions. So absolute value function y equals absolute value of x can be graphed by picking values of x and finding corresponding values of y. There is no restriction on the domain, so we are free to pick any x values we want. I'm going to pick the ones closer to origin so that my graph, I can get a good shape on my little graph I have here. So we're going to go ahead and pick x as -3. Corresponding y value will be +3 because absolute value of -3 is +3. And pick x as -2, -1, 0, 1, 2, 3. Find the corresponding y values and plot these points and connect the dots. We can see the graph of absolute value function looks like a V-shaped graph, the letter V in the alphabets. Today we're going to talk about translations and transformations on this graph. So we'll start talking about translations. Translation is something that shifts the graph horizontally or vertically, but doesn't change the overall shape or orientation of the graph. So it would not make it narrower or wider or stretches or shrinks. It will just move it up, down, left, right. So translations move the graph up, down, left, or right. First, we're going to talk about the graph of y equals absolute value of x minus h plus k. This new graph will be shifted h units to the right and k units up. So the original vertex was 0, 0 for basic absolute value of function y equals absolute value of x. That vertex will be shifted to hk now. The new vertex will be hk. So shifted h units to the right and k units up. We're gonna look at some examples of horizontal shifts for this graph. For the horizontal shifts, first example is y is equal to x plus 2. When the number is subtracted inside the absolute value function, shifts the graph to the right that many units, whatever h is. If that number h is added inside the absolute value function, it would be shifting the graph to the left that many units. So here we have y equals absolute value of x plus 2. It would be, because it's added inside, it would be shifting graph 2 units to the left. Because think about the y-intercept. The y-intercept is whenever x is 0. So if we y-intercept would be whenever x is 0. So if x is, think about x-intercept. Scratch that, think about x-intercept. X-intercept is whenever y is 0. And where is y going to be 0? When x is -2 here. The next one, y equals x plus 1. Absolute value of x plus 1. Where is going to be the x-intercept here? Whenever x is -1, y will be 0. That's going to be the x-intercept. And the next one, y equals absolute value of x minus 3, will be shifted 3 units to the right. So when there's a negative inside the parentheses, inside the absolute value symbol, it's going to be shifted to the right. When there's positive inside, it's going to be shifted to the left. Keep that in mind, because where is this graph going to have the x-intercept? Whenever y is 0, which is going to happen when x is +3. And the next graph, y equals absolute value of x minus 1, will have x-intercept whenever y is 0, which means when x is equal to +1. So origin or vertex of the graph gets shifted from 0, 0 to this new vertex. For this graph, the vertex gets shifted to -2, 0 and -1, 0. And here it's going to be 3, 0, and here it's going to be 1, 0. Right, let's see some vertical. Here we're going to write equations for some of these graphs that are given to me. So because I have a shift which is left or right, I'm going to be adding or subtracting a number inside. If it's a shift to the right, the number will be subtracted. If it's shift to the left, the number will be added. So first graph shift, because the shifted to the right, the number will be subtracted. So it would be x minus 2. Y equals x minus 2 absolute value. Y equals absolute value of x plus 3. Shifted to the left, so x plus 3. So if it's plus inside, shifted to the left. If it's minus inside, the graph is shifted to the right. Okay, the next one, y is equal to absolute value of x plus 6. And the last one, it is shifted to the right, so x minus 8. I'm going to talk about a few vertical shifts. For vertical shifts, keep in mind if the number is added after the absolute value of function, so f of x plus k will shift the graph k units up, f of x minus k shifts the graph k units down. Here's some examples. Absolute value of x plus 2 will shift the graph 2 units up. The origin will be shifted 2 units up. The new origin will be 0, 2. And the next one, the graph will be shifted 5 units up. New origin will be 0, 5. Next graph will be shifted 3 units down. New origin will be 0, negative 3. And y equals absolute value of x minus 1 will be shifted 1 units down. And the graph origin would be 0, negative 1. Let's see, writing the equations for some of these graphs. They are all vertical shifts, so I'm going to be adding a number or subtracting a number after my absolute value function. So it will be absolute value of x. Because it's moved up, it would be plus 3. The next graph is moved down, so it will be absolute value of x minus 8. Notice I'm adding the number after my function. This number is not going inside my function. If the number is going inside the absolute value function, then that shifts it to the left or right. Number going after the absolute value function moves it up or down. The next one, it's shifting down, so it would be absolute value of x minus 4, y is equal to absolute value of x plus 6. Reflection over x-axis, so if we have a negative in the front of absolute value function, that's going to reflect our graph over x-axis. If there's negative in front of the function, then the graph will be reflected over x-axis. So graph of y equals negative absolute value of x would be reflected over x-axis. Reflection over y-axis, we wouldn't talk about it because if the negative goes inside your function, inside the absolute value, that's going to cause a reflection over y-axis. But because it wouldn't really affect the function because absolute value, it will reflect the function over y-axis, the left portion will reflect to the right portion and take over, and the right portion will reflect. It would be unchanged. The graph is going to be same because it's symmetric over y-axis. So reflection over y-axis is not going to show any change in the graph. Graphing absolute value functions. Now we're going to talk about a few different graphs. We're just going to be sketching the graphs, thinking about the origin first, and then thinking about what kind of changes are there from the basic parent function that we have at 0, 0, whose vertex is 0, 0. So the first one, my vertex is going to be for this new graph 3, 2. X is 3, y is 2. So 1, 2, 3, 1, 2. This is my new vertex, and every single point on the basic absolute value function will be moved 3 units up, 2 units to the right. I'm sorry, nope. 3 to the right, 3 units to the right, and 2 up. 3 units to the right, 2 units up. Because h is 3, k is 2. The next graph, number 2, let's talk about that now. We do have, for graph number 2, we have a reflection over x-axis. For graph number 2, reflection over x-axis. And we would have the new origin would be negative 2, 1. So this graph is shifted 2 units to left, 1 up. So 2 to the left, 1 up, and it is reflected over x-axis. So something like this will be the shape of my graph. Now let's talk about number 3, problem number 3 here. For number 3, we do have a reflection over x-axis. So reflection over x-axis, and the new origin would be negative 3, negative 2. In this case, the origin will be shifted from 0, 0 to negative 3, negative 2. Each point on the basic parent function will be shifted 3 units to the left, and 3 units to the left and 2 down. 3 units to the left and 2 down. So 1, 2, 3, 1, 2, and it is reflected over x-axis, and that's going to be the overall shape of my graph. Sketching, stretching and compression. Now we're going to be talking about transformations. So if there's a number in the front of absolute value symbol, that number is actually it's gonna change the shape of our graph. It's not just gonna move it horizontally or vertically. It's gonna change the shape of the graph. It's gonna make it narrower or wider. It might shrink it, it might stretch it. So let's see what happens when there's a number in the front. If that number is if absolute value of that number is greater than 1, then the graph will be vertically stretched and will be narrower. If absolute value of the number is greater than 1, then graph will be vertically stretched and narrower. If absolute value of that number is less than 1, graph will be vertically shrunk, or it would be a wider graph. The value of a acts like the slope. This is going to be very, very helpful when we make our graphs. The a acts like the slope for graph of the function. Here's an example. We're going to go ahead and make this graph. Let's think about it. We do have reflection over x-axis. And the new vertex for this graph would be -1 and -2. And from there, this point 3 acts like the slope. 3 acts like slope. So let's go ahead and try to graph this function where start with x -1, y -2. So there's my new vertex, and there is a reflection over x-axis, so it's going to be opening down, and then we can see the 3 is going to be the slope. So if 3 is the slope, or we can say 3 over 1 is the slope, go down 3 over 1, down 3 over 1. So I do have 2 new points. I'm going to mark all the points on my graph, label them. So my origin was -1, -2. If we went down 3 from here, I would be at 0, -5. And on this side, I would be at -2, -5. So just using the slope and origin, we shifted the original graph and we got the new graph. Domain and range of absolute value functions. Domain is all real numbers. Range can vary. Like in this case, domain is all real numbers, but the range, this graph will never go above -2. It's always going to be going down. So range will be -2, -infinity to -2 with a bracket around -2 for the y value. Let's grab one more function, y equals 2 times absolute value of x plus 2 minus 3. So there's no reflection over x-axis in this case, but new vertex would be -2, -3. New vertex is -2, -3. And 2 acts like a slope. Or we can say 2 over 1 acts like a slope if that feels any better. So let's go ahead and plot this graph. X is -2 and -3, 1. So here's my new origin, new vertex for this shifted, translated absolute value function. From here, we can see that 2 is going to act like a slope. So I'm going to go up 2 and over 1, up 2 and over 1. And that's going to be somewhat shape of my graph. I'm going to mark all the important points, label them on the graph, -2, -3, and this point would be -1, -1, and this point would be, the y value would be still -1, x would be -3, -3, -1. So that's the graph of this given function. Again, the domain is all real numbers. It's going to eventually take all the x values, but the range for this graph, it only stays above -3. It takes positive y values and all the negative y values above -3. Next, we're going to summarize all the transformations. So negative in the front is going to be reflection over x-axis. The a in the front is going to make your graph stretched or shrink it. If absolute value of a is greater than 1, it's going to make it narrower. If absolute value of a is less than 1, it would make it wider. The number inside your absolute value function will be a horizontal shift, means it's going to move it left or right. It's going to do opposite of h. If it's a plus inside, it will shift your graph to the left. If it's negative inside, you'll shift it to the right, and the number that comes after the absolute value function will be a vertical translation. We'll move it up or down k units. If it's plus k, k units up, minus k, k units down, the new vertex will be hk. That's all for graphing absolute value functions.